Let us evaluate the integral of sine to the power of 9 of x. When dealing with an integral of sine or a cosine and your exponent here is an odd number, this should be the trigonometric identity that you would want to use, which is sine squared of x plus cosine squared of x would be equal to 1. Since what we have here in the problem is sine, we would want to isolate this one. So transposing cosine squared of x to the other side, this would be sine squared of x equal to 1 minus cosine squared of x. The objective of this would be to put the problem into sine squared of x form. Since this is an even form, we would want to factor out 1 sine of x here in order to make it also even. This would be sine to the power of 8 of x multiplied by sine of x dx. Keep in mind, multiply this together and you have the same problem. Next up, since what we want to have here is a sine squared of x, we would want this to be condensed. And so this would be the integral of sine squared of x raised to the power of 4, because 4 multiplied by 2 would be simply 8. And copy the rest. Now that we have this, we would want to transform it. Rewriting that, this would be the integral of 1 minus cosine squared of x raised to the power of 4 multiplied by sine of x dx. Now that we have this, we would want to expand this. This is a binomial theorem with the exponent of 4. And so, the formula for this would be a minus b squared would be equal to a to the power of 4 minus 4a cubed multiplied by b plus 6a squared multiplied by b squared minus 4a multiplied by b cubed plus b to the power of 4. This was based on the binomial theorem, with a here representing 1 and b here representing cosine squared of x. Applying that to the formula, this would be a to the power of 4, which is simply 1 to the power of 4, is simply 1 minus 4 multiplied by a cubed is simply 1. Multiply that by b, which is cosine squared of x, plus 6a squared is 1, b squared is cosine squared of x, and raise that to the power of 2, which will give you a value of cosine to the power of 4 of x, minus 4a is simply 1 again. Multiply it by b cubed, cosine squared of x to the power of 3 is simply cosine to the power 6 of x, plus b to the power of 4, cosine squared of x to the power of 4, which will give you a value of cosine to the power of 8 of x. And copy the rest here. As you can see, inside the parentheses, there are a lot of cosine values in there. So we would want to use a technique called U substitution. Whenever you use U substitution, you would want to take the derivative of that. So let U here be the cosine value, which is cosine of x. And take the derivative. The derivative of cosine of x is simply equal to negative sine of x. And since this is with respect to x, multiply it by dx. Whenever you encounter something like sine of y or any variable, it is respect to y, so this would be dy. But since what we have here is respect to x, this would be dx. And since what we want here is to isolate dx, in order to substitute it on that, isolate it, this would be dx equal to du over negative sine of x. Now that we have our value, let us put it. So this would be the integral of 1 minus 4 cosine squared of x here would be equal to u to the power of 2, since u here is simply cosine of x, plus 6u to the power of 4 minus 4u to the power of 6 plus u to the power of 8 multiplied by sine of x and multiply it by the value of the x, which is du over negative sine of x. You can see here that sine of x would actually cancel, which leave you with a negative 1 value. You can actually put that outside the integral. So this would be simply, and what you're left with here is du. And now you are left with this integral expression. Now that we have this in a much simpler form, we can now integrate this one by one. So let this be negative and put a bracket which represents the value of this integral. Now, the integral of 1 du is simply u minus 4 multiplied by the integral of u squared is u to the power of 3 over 3, which is based on the power rule, plus 6 multiplied by the integral of u to the power of 4 would be u to the power of 5 over 5 minus 4 multiplied by the integral of u to the power of 6, which is u to the power of 7 over 7 plus the integral of u to the power of 8, which is u to the power of 9 over 9, and add the constant of integration. Simplify this and also distribute the negative value amongst this bracket. This would be negative u. Negative here and negative would make a positive sign, which is plus 4/3 u to the power of 3 minus 6 over 5th u to the power of 5 plus 4 over 7 u to the power of 7 minus u to the power of 9 over 9, or let's put it 1 over 9 multiplied by u to the power of 9 plus c. Remember, the signs here will switch because of the negative sign outside. In order to get the final value of this integral, you would want to put u back into its original form, since you originally had substituted it. So your final answer here would be equal to negative cosine of x plus 4/3 cosine cube of x minus 6 over 5 cosine to the power of 5 of x plus 4 over 7 cosine to the power of 7 of x plus 1 over 9 cosine to the power of 9 of x plus c. There, that is your final answer.